So get this, a laser beam with no more power than a tiny nightlight was just fired from 36,000 kilometers up in space, and some people are calling it a Starlink killer. Today, we're going to find out if that's actually true or if the real story is something way more interesting. You've probably seen headlines just like this one popping up all over the place. They're painting this picture of some kind of dramatic showdown in orbit. The claim that a brand new Chinese technology has just completely left SpaceX's Starlink in the dust. So, is this really it? Is this the Starlink killer everyone's talking about? Well, let's cut through the hype. We are going to break down the incredible science behind this achievement and see what it really means for the future of how we all get connected. Okay, let's dive right in. What did this Chinese satellite and its little laser actually do that got everybody so worked up? You know, at its heart, this is just an incredible piece of engineering. A team from Peking University and the Chinese Academy of Sciences managed to transmit data at a blazing fast 1 gigabit per second all the way from a satellite 36,000 kilometers away. And they did it with a laser that has just 2 watts of power. That's barely enough to run a small nightlight. To really get why this is such a huge deal, you first got to understand the 2 main ways we talk to satellites. For decades, we've used radio waves. Think of them like a reliable old highway. They get the job done even when the weather's bad. But man, are they getting crowded, and that just slows everything down. Lasers, on the other hand, they're like a private, super-fast monorail. They can carry way more data, and they're a lot more secure. But here's the catch. That monorail can get totally shut down by a bit of bad weather, or even just by the air getting a little shaky. And that's the billion-dollar question, right? It's something that has stumped engineers for years. I mean, sending a tiny pinpoint laser beam through thousands of kilometers of swirling air without it getting all scrambled, that is incredibly difficult. Well, it turns out the Chinese team came up with this brilliantly clever 2-part system to solve this exact problem. Their solution is this amazing 1-2 punch of hardware and software. So first, you have a system of hundreds of tiny, fast-moving mirrors that act kind of like a pair of smart glasses for the telescope, instantly refocusing that wobbly laser beam the second it arrives. Then, some really clever software takes that corrected beam, splits it into a bunch of different channels, and intelligently picks out the strongest parts of the signal to decode. It's just a brilliant way to piece the original message back together again. And the result of all this? Their system boosted the signal's success rate to over 91%. That is a massive leap forward from older systems. To go back to our analogy, they basically figured out how to make that fragile monorail run reliably, almost all the time. Okay, so now for the reality check. Let's see how this amazing experiment actually stacks up against the massive operational network that is Starlink. And here's where the whole comparison gets a little tricky, because you see pretty quickly that they are built for completely different jobs. The Chinese test satellite is way, way up there in a geostationary orbit, 36,000 kilometers high. Starlink satellites, they're much, much closer, down in low Earth orbit. And that difference in distance, it changes everything. We're also comparing one single experiment to a massive global commercial service. So yes, the speed of that one Chinese test link was way, way faster, 1,000 megabits per second. But, and this is a big but, it's not an apples-to-apples comparison. That was a dedicated one-to-one connection. Starlink's average speed is lower because it's a shared network providing service to millions of paying customers, all at the same time. But you know, speed isn't the whole story, not by a long shot. For the kind of internet we use every day, the most crucial factor is something called latency. That's the delay it takes for your signal to travel all the way up to space and come all the way back down. For stuff like video calls or online gaming, low latency is everything. Because that geostationary satellite is so incredibly far away, you get this round-trip delay of at least 240 milliseconds, and there's just no getting around that. It's a law of physics. By comparison, Starlink's closeness gives it a latency under 50 milliseconds. That quarter-second difference, that's the kind of lag that makes a video call truly frustrating. And let's not forget some other key facts here. This was one successful test, not a service that's ready for millions of people. Lasers still can't see through thick clouds, but radio can. And this is kind of ironic, Starlink already uses a huge network of lasers itself, but it uses them to link its own satellites together up in space, creating this super fast data backbone that stays way above the weather.
So, if this tech isn't about to obliterate Starlink, then why does this achievement matter so much? Why are we even talking about it?
Because it opens up a whole new world of possibilities for things where a quarter-second delay doesn't really matter, but moving massive amounts of data does. Think about a deep space probe sending back huge scientific data sets, or the military needing to download enormous surveillance files securely. This is a total game changer for big data, not for your next Zoom call. So the real takeaway here isn't that one system beat another. It's that the future of space communications is going to be a mix, a hybrid. We'll use these low Earth orbit constellations like Starlink for our low latency, everyday internet, and then we'll use these powerful, high orbit laser links for specialized, high volume data transfers. It's all about using the best tool for the right job.
So, in the end, this isn't a zero-sum game at all. Every single one of these breakthroughs, whether it comes from Starlink or the Chinese Academy of Sciences, it just pushes the boundary of what's possible. It leaves us with a new question. Not who will win the space internet race, but how will this new toolbox of lasers and satellites connect not just our world, but maybe the next one we decide to visit?